Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we begin Chapter 9, which is the conics section, and that's the study of a lot of different figures. Parabolas and circles are two of which we're going to study today. We'll get ellipses and hyperbolas in a later video. We'll also pick up the distance formula and the midpoint formula, which are good formulas to know to help aid us in graphing some of the conics. So conics is the study of a cone, and if they're cross sections of a cone, and you can get the circle, the ellipse, the parabola, and hyperbola. And again, we're looking at the parabola today and the circle in this video. But I wanted you to recognize kind of the general equation of each. Notice that if both terms are being squared, it's either a circle or an ellipse or a hyperbola. But if only one term is being squared, it's got to be a parabola, which is what we're looking at for today. And then if the A term and the B term are equal to each other, then it's going to be a circle. So those are the two that we're going to look at today, is a circle, a parabola, and I'll explain that in a moment. Again, here's what your parabola looks like and your circle looks like. These are the two that we're going to study today in this video, and I'll talk about ellipses and hyperbolas in a later video. So the parabola, again, is a cross section of a cone, and it's just going to slice a slant parallel cut through it. So two different types of parabolas. We could have parallel to the y-axis, and we could have parallel to the x-axis. Perhaps you're familiar with the most common parabola, y equals x squared. You can see that this is has symmetry about the y-axis. So notice that's y equals x squared, and this is x equals y squared, which I don't think you've studied before, but that's going to have symmetry with the x-axis. This is actually not a function because it doesn't pass the vertical line test. So here are some notes that I've typed up. We're going to be exploring how to find the vertex, the focus, the directrix. The focus is what helps generate the parabola, and the directrix, the definition of a parabola is all the set of points that are equal distance away. So this red distance equals this red distance. This distance here in green equals this distance here. That's perpendicular. And so that's what generates it all. And then we have symmetry. This actually should be a negative 4a because it's actually going to the left. So I'll post these notes on Blackboard if you would like to download a PDF file of these notes. But make sure you throw a negative in there. So if it was a positive 4a, it would go to the right. If it's a negative 4a, it goes to the left. Down here, this is correct, it's positive, and if I would have written it as a negative 4a vertical, it would have gone down. So taking a look at our first example, this is in standard form, but not standard graphing form, so we can go ahead and complete the square. I like to throw the 10 over on the other side, although you don't have to, but to complete the square, to get it into a standard y is equal to a x minus h quantity squared plus k, where the vertex is going to be defined as h and k, we complete the square. So to complete the square, we do half the middle term, which is 6 divided by 2, and square it. So 6 divided by 2 is 3, 3 squared is 9. So 9 is that magical number that's going to help us complete the square. So over here I actually get y minus 1 is equal to x minus, and then whatever this number here is, 6 divided by 2, goes here. And incidentally, whatever sign this is goes here. So 6 divided by 2 is 3. And so the equation that I'm looking for here would be y is equal to 1, x minus 3 quantity squared plus 1. So you could see that the vertex is 3, 1. So I'll plot that right here. And then I'm given the value of a, and a is 1. So I can just go over 1, up 1, over 1, up 1, and find 2 more points, and I know that I have symmetry. So that's a fairly good graph. If you would like to find additional points, you can. Just plug in for x and solve for y, but you can see there's your 0.31, and that value of a is telling me go over 1 up a. Again, using the notes that I've given you to find the vertex, if it says y squared is equal to 8x minus 0, we can see that the vertex is 0, 0. It's centered around 0, 0. To find the focus, we need the distance of a. So this is actually right here defined as 4a. So if I set 4a equal to 8, then I get the distance of a to just be 2. And so if I plot the vertex at 0, 0, I'm going to go 2 units, and then I have to decide, well, I know it's positive, so I either go up or I go to the right. And since it's y squared equals 8x, this is going to be a horizontal, and it's positive, goes to the right. So the a term is 2. So there's the focus at 2, 0. The directrix is going to be the same distance away the opposite direction. So that's at x equals negative 2. And I haven't talked to you about the latus rectum yet, but the latus rectum is the distance, well, it's in this yellow. It's really 4a. And so, well, it's defined right here. 4a is equal to 8. So I know that the distance of the latus rectum is 8. So I'll go 1, 2, 3, 4 above, and 1, 2, 3, 4 below. So the latus rectum will just be this total distance here of 8, and that just helps define how wide my parabola is. A little bit better picture of it is right here. So again, that latus rectum is this red line, and it's this 4a number, in this case 8. So I just find the focus and go 4 above and 4 below to find 2 good points. So again, this slide is just telling you all the different ways. The focus is what the parabola goes around, and the directrix is all the set of points that are equal distance from the focus to the directrix. So for this one, it looks like, again, the vertex is going to be 0, 0. Because I could write it in this form. So this is still going to start at the center. Since it's in the form x squared equals 4a y minus k, I know that it's a vertical. So it's either going to go up or down. It's going to go up because the value of a is positive. I'll find a by setting, oh no, it's going to go down because the value of a is negative. So I'll set 4a equal to negative 12. So a is equal to negative 3, so I'm going to go 3 units down to find the focus. And by the way, 3 units up. So this is a y equals 3. And the focus is going to be at 0, negative 3. And again, the latus rectum is this 4a business, which is, well, it's actually negative 12, but it's the distance. So it's 12 units, so I'll go 6 units to the right. 3, 4, 5, 6, and put a point there, and 1, 2, 3, 4, 5, 6 to the left. Again, that just helps determine how wide the parabola is. So this total distance in here is 12. A little bit better picture, so you can identify what these 2 points are here. Another way to graph parabolas is to find the vertex by not completing the square, but using the definition negative b over 2a. That'll tell me the x-coordinate of the vertex. So negative b over 2a is if it is a 3 in this case, which it is for this particular problem, then I know that the vertex is 3 comma something, and to find the something I just go to the function and evaluate it at 3. So that's what they're doing here. Just plug in a 3 every time you see an x, and it turns out to be 1. So this vertex must be at 3 comma 1. So we'll try an example using graphing techniques of parabolas using the negative b over 2a. Be careful, we could also talk about whether it's a vertical or horizontal parabola. So looking at this one, I can tell that it's a horizontal parabola because it's in the form x equals y squared. So, and because it's a negative, it must be going off to the left. So generally speaking, I know it looks something like this, but I don't know the vertex or how wide it is yet. So be careful for horizontal parabolas. If I try to do the negative b over 2a, that's actually going to be the y coordinate instead of the x coordinates. So because everything is reversed here. So if I were to do negative 6 over 2 times the a value, again, this is your ay squared plus by plus c, then this turns out to be negative 6 over negative 2, which is a positive 3. So that's telling me that the vertex is something, so I have to go to the function and evaluate it at 3 to find the x-coordinate this time. That might be a little confusing, so you may choose just to complete the square for this. So I'll add 7 to both sides, factor out a negative 1, leaving me with y squared minus 6y, and I'll try to complete the square. Again, I write this as the star step because that reminds me to take half of the middle term and square it. So half of 6 again is 3, squared is 9. So it looks like I added 9, but I actually added a negative 9 because if I distribute the negative 1, that's a negative 9. So this is really x minus 2 is equal to negative 1, and I've completed the square. This is y minus 3. Remember, it's always just half the middle term. So whatever number this is here, and whatever sign this is, that's what this is. So finishing this back up, this is squared. I get x equals negative 1, y minus 3 quantity squared plus 2. But if I were to keep this in this x minus h is equal to y minus k, then I can see that the vertex is actually coming from this guy, negative 2, comma 3. We already knew that this was a 3 because of what we had done before. So again, I could plot that point as the vertex, negative 2, 3 goes here. I'm sorry, I just made a classic mistake. Every time you see parentheses, you just go the opposite direction. So when x minus 2 equals 0 when x equals positive 2. So this should have been a positive 2 here. And the vertex should have actually been over here at positive 2, 3. So there's the vertex. Again, I know that it's going to the left because of our earlier discussion, and I noticed that I had a negative a term. And the value of a this time is 1. So I'm going to go over 1 up 1 and over 1 down 1. And I know it shoots off to the left because of my negative a term. Again, if you wanted to find additional points, you can just plug those in and graph it. So negative b over 2a is a nice way to find sometimes the x-coordinate, sometimes the y-coordinate, depending on whether it's horizontal or vertical. Moving on, we can talk about the distance between 2 points. Either we could do it with a horizontal or a vertical line, or we could do it with a diagonal. And so this is just the proof of any 2 points in general. We're going to subtract to find the distance of 2 points. So here comes a nice formula. The distance is always the square root of the change in x plus change in y. And it kind of looks like a formula that you might be used to, because it kind of looks like a squared plus b squared equaling c squared, but the letters just kind of changed a little bit. So that's what we do for right triangles. So remember, take the difference here, but this is really kind of like a squared plus b squared, where a is the change horizontally and b is the change vertically. So giving an example, I'll plug these x and y ordered pairs into the distance formula. So my first x is 3 minus 5, and I'll add 1 minus a negative 6 quantity squared. So my distance is the square root of, this is going to be 4 plus 49, which is the square root of 53, which if you wanted to punch that in the calculator and get something approximate, 7.28. The author agrees it's similar. Midpoint is the average, so to find the midpoint we just add up the x's, x plus x divided by 2, and y plus y divided by 2 is a nice midpoint formula. And that works for horizontal, vertical, or slanted lines. So an example of the midpoint here if I add the x's, 5 plus 3 divided by 2, and then 1 plus a negative 6 divided by 2. And I'll just put this in ordered pair. So 8 divided by 2 is 4, and negative 10, negative 5 divided by 2, I'll just leave it. So the midpoint is 4 comma negative 5 halves. Well, the distance is important because I define a circle by all the set of points that are equal distance away from the center. And we're going to define the center as h and k, and the radius is that distance away from the center to any point on the circle. So if I were to ask you to write the equation of a circle, it also looks like a squared plus b squared equals c squared, because it's just by the definition all the set of points that are equal distance away from. So it's either the distance formula, or you can see that I've got nice right triangles in here. So this is centered about 0, 0, and then in general this is the equation if I change the center h and k and relocate it. We'll probably mostly be using this one, but if it is centered, we'll use this one. So here are the notes that I use as well. If I were to try to write an equation here, it looks like the center is 3 comma 2, and maybe the radius here is 3. So to write an equation, I would say x minus 3, which is the x coordinate, plus y minus 2, which is the y coordinate, those are being squared, equals 9 because it's the radius squared. So going backwards, if I give you the center, it says write an equation. So that here it is. Oh, same thing. X minus h quantity squared plus y minus k quantity squared equals r squared. So I'll just plug it in. X minus 1 quantity squared, y minus 7 quantity squared equals 4 squared. I'll probably just change that to a 16. If I was to graph this, I'll start at 1, 7, which is off my graph. And I'll probably go a radius of 4. So go 1, 2, 3, 4 to the right, 4 to the left, 4 down. Well, 4 down from 7 is at 3, and then 1, 2, 3, 4 up. So I'll find those 4 points, and then best I can just draw a circle. So if it's not in the standard form, then again we need to collect like terms and try to complete the square. So 2x plus blank, so I'll complete the square for those. I'll collect the y terms together. Y squared minus 6y plus some number. And I'll say equals, and I'll throw the negative 6 over here. But since I have 2 nice blanks on the left, I'll have 2 blanks on the right. Completing the square says take half this middle term and square it. So half of 2 is 1. 1 squared is 1, so I'm going to add that to both sides. Complete the square over here. 6 divided by 2 is 3. 3 squared is 9. So if you add 9 over here, add 9 over here. This red turns up to be x plus 1 quantity squared. Remember, I don't have to think hard because it's just this number. Plus y minus 3 quantity squared. Remember, it's just that number here. Equals, and I'll just say, oh, this is 10, take away 6, which is 4. And then I know that my center is, whenever you see parentheses go the opposite direction, negative 1, 3, and the radius must be 2. So to graph this, negative 1, 3 is here. And then I'll just go 2 in every direction. 2 to the right, 2 down, 2 to the left, and 2 up. And then carefully draw in the circle as best I can. So again, the author gets the exact same answer and plots and labels the graph. If you have any questions, feel free to email me. I hope you found this video helpful.